resistances applications we are going to discuss. Current electricity. In this current electricity chapter, we are going to discuss the resistances combinations applications. Already in last class, we discussed the series and parallel combination of resistances. Now, if the three resistances are supposed like this, one connected to another, R1, R2, R3, what is the effective resistance? Effective resistance in series combination simply R1 plus R2 plus R3. And like that, what is the effective resistance in parallel combination? In parallel combination means our formula, what we discussed yesterday in parallel combination is, suppose this is R1, R2, R3. All the resistances are between the same points A and B. Here the point is A, here the point is B. So now what we can write in this regard, R effective means 1 by R effective is equal to 1 by R1 plus 1 by R2 plus 1 by R3, 1 by R3. So now effective resistance formula we can write like that. Further what we can write here, if you take LCM, you will get R effective equal to R1, R2, R3, LCM and reciprocal, you will get this value. R1, R2 plus, R2, R3 plus, R3, R1. So I have taken LCM and reciprocal, that one. This is the effective resistances when three resistances are in parallel between, connected between same points. R1, R2, R3 connected between A and B. Then this is the effective resistance. Next one we'll see, if suppose two resistances are in series and one resistance in parallel, two like that. So here the points I'm taking it as A, B, here 2 points. So if the 2 points are A and B are like that, what is the effective resistance they're asking? Here let me take, this is R1 and this is R2 and this is R3. If we observe now how R1 and R2 are there means, R1, R2 are connected one to other. This type of combination we already know. It is called series combination. Series combination. So now instead of that combination, I can write simply only one resistance. Instead of R1 and R2, I can write now only one resistance. What is the value of that resistance? Here R1, R2 are in series. Series means what we have to write? R1 plus R2. You can observe this R1 and R2 are in series combination. Series combination. So instead of that, the effective resistance what I am writing here is R1 plus R2. Now if you observe carefully here, this R1 plus R2 and R3 are between same points. They are between same points A and B. R1 plus R2 is also between A and B. R3 also between A and B. So what is the effective resistance when these two are? This type of combination we call it as parallel combination. Parallel combination. Now what are parallel? R1 plus R2, R3 are parallel. So that I can write effective resistance as R1 plus R2 parallel to this one. So in parallel combination, we can write directly like this, R1 plus R2 plus R3. Original method is, we have to write like this, 1 by R effective is equal to 1 by R1 plus 1 by R2, 1 by R1 plus 1 by R1 plus R2 plus 1 by R3. If you simplify this one, if you simplify by doing LCM and reciprocal, you'll get this expression. So this is the effective resistance in that regard. So What we observe here, observe carefully, two resistance in series, A and B are at the ends like this. Suppose now, in one question, they have given like this, that is A and B are the two, that means the resistances, here R1 and R2 are two resistances and they are between A and B, no doubt. But we are not taking previous A and B. Now what we are doing means the point B is taken somewhere in between. B is taken somewhere in between. And this point, let me take C. I want effective resistance between A and B only. I want effective resistance between A and B. So I want effective resistance not between A and C. I want effective resistance between A and B only. Effective resistance between A and B. In such type of things, how to handle means, here you take this as, now let us take this as some R3. Now when we observe these points, so leave the term C, and now I can rewrite this one like this. This point is what I wrote is here A. Now this point is A and this point is B. And these two resistances, if you observe, R1 and R2 are connected like this. R1 and R2. Leave the point C first. Because they're not asking between A and C. They're asking between A and B. Leave the point C. Now, if you observe, R2 is between what and what? R2 is between A and B. Now the combination of R1 and R3, if you observe, they are also between A and B. R1 and R3 are one connected to another. Because it is said to be in series combination. They are said to be in series combination. So observe carefully, this R1 and R2 or R1. Here this is A connected to here and B connected to. This combination is between A and B only. So I can rewrite the diagram like this better. So now one resistance is what here? R1. Another resistance is what here? R2 and R3. R2 and R3. And your points are A. And your point is B. So A and B. Now, how R2 and R3 are connected? R2 or R3 are connected in series. Series combination. Series combination means R2 plus R3. Now if you observe R2 plus R3 and R1, this total combination, how it is? If you observe the total combination, so this R1 is between A and B. R2 and R3 are also between A and B. So now what I can conclude here, R1 and this combination R2 plus R3, both are between A and B. So let me write again here. So this is R1 and finally this is R2 plus R3, R2 plus R3. They are between A and B. So they are between same points, mean they are parallel. Parallel means I can write R effective is equal to R1 into R2 plus R3 by R1 plus R2 plus R3. This is the effective resistance in parallel combination for two resistances. We are taking R2 plus R3 as single resistance value. R1 also single resistance value are taking. Then these two combination parallel. R1, R2 actually if suppose is RA, this is RB. RA by RA into RB by RA plus RB. Like that I can write here. I hope this topic is clear till here better. Now let us see one more application here. Here now what happened, the resistances you know. First I have taken like this, the two resistances and I named them as R1 and R2 and they're connected like that and R3 is connected like that. Already I have given you this information and this point is A they told, this point is A they told and the B point is B point they are taking here. So B point in previously there we have to, this is the B point. So A and B means now also here if you observe direct one only, already we discussed if B is here or here it doesn't matter because there is no resistance in between them. So here A R1 R2 in series, R1 plus R2 and R3 is parallel to this combination. So simply R effective is equal to R1 plus R2 into R3 by R1 plus R2 plus R3. Like that I can write. So now if at all I have taken the points like this, there are three resistances are there. Now this point is A, this point is A, R1, R2 and R3 is there. Now suppose where should we take the B point means already once we have taken the B point in between R1, R2 and again we have taken between R2 and R3 also. Suppose here let us take one more resistance. We'll introduce one more resistance here. This is R4, R4 and all are equal to R, all are equal to R. So here R and R, R1, R2 are equal to R and R2, R3 and R4 both are equal to 2R. And this is A and this is the point B. Now how the combination, what is the way to take the effective resistance in this way means, we observe very clearly here, first these two are in parallel. Because this point is A means I can make it to travel till here until there is no resistance I can bring that one. So here also until there is no resistance B can come till here, B can also come till here because no resistance in between. So here it cannot travel here because there is resistance here. This A can't travel this direction because here also resistance is there. B cannot travel here because resistance is there. From this junction, B cannot travel. So until there is no resistance, B can travel till that junction. So A can travel till here. So now if you observe, first these two resistance A and B, like that they are. Let us see once again what happened better here, how to handle this situation we'll see from starting onwards. Again here I'm drawing this one. So here what is the resistance means, first one is 2R, I have taken, sorry I have taken it as R and R, two resistances are there. So two resistances R and R, there are two resistances. Next I have taken this as 2R and next I have taken down also one more 2R. This is a given question for us and these are the points A and B. I told that A can come down like this and B can also come down because there is no resistance points. That means A we are writing here, here also. B we can write here and here also as there are no resistances. So if you observe, these two resistances are between A and B. So this is also 2R is also between A and B, 2R also between A and B. First one, R and R, how they are? R and R, they are in series. Series means 2R. So 2R, 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 all the 2Rs are between A and B. Then what is the R effective formula means? If three resistances all are identical, 2R, 2R, 2R are parallel, then I can write it as 2R by 3, 2R by 3. 4 2Rs are parallel, 2R by 4. 5 2Rs are parallel, 2R by 5. Effective resistance for identical in my last class I have given RP is equal to R by N. Here 2R is parallel like that, all the 2Rs are parallel. How many 2Rs are there? 3 2Rs are there. So 2R by 3. Like that I can write. Next one you observe here. If suppose the question is given like this. 2R, 2R. R, 4R. What is the effective resistance between A and B? Now, as usual, this A I can write here, and I can also write here because there is no resistance in the junction. Still, the junction we don't have resistance. B can be also written here. Now you observe here, first 2R, they are in series. 2R series means 4R. R, these all are in series. That is also 4R. Now 4R, how many are there? 3 are there. So R effective is equal to, simply I can write 4R by 3. 4R by 3. Like that I can write. Just extension to our previous topic only. Next, if you observe, suppose they are giving the resistances in this way. So here what happened means 3R, 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 like that 3 resistances are there. And here what happened, they are taking 2 resistances, that is 2 resistances are given like that. And what is the effective resistance between A and B? Effective resistance between A and B. Now, first you observe carefully, all are between same points. All are between same points. Everything is between these 2 points. So all are between same points, all are in parallel. So R effective means here first one, this is parallel combination. What are parallel? How many are parallel? 3 are parallel. Each one value is 3R. So 3R by 3 plus. Again, if you observe this one now, here 2R and 2R are in parallel. 2R and 2R are in parallel. So now this total combination is series with this one. This combination, how they are linked with means we can say series. Series means addition. That's why I have taken here positive sign. I have put here positive sign because this total combination are in series. Series means you have to add. So now 2R, they are parallel. 2R parallel means what we can write here. 2R parallel means 2R by 2. So from here, first 3 cancel, 2 cancel, I can cancel 3 I can cancel 2. R plus R is equal to 2R. I can write the expression as 2R. I hope it is clear how I handle this situation. Let us see one more situation here. They are given like this, that is one resistance, other resistance, like that. All are identical. These all are 2 ohms, 2 ohms, 2 ohms. Everything is 2 ohms they have given. And here also 2 ohms, 2 ohms and 2 ohm resistance. And this one also some 2 ohm resistance. All are 2 ohms. 2 ohms, 2 ohms, 2 ohms. This is the question given to us. And in between also some resistances are there. This resistance is 3 ohms, 3 ohms. And this resistance is again 3 ohms. What is the effective resistance between A and B? What is the effective resistance between A and B? The question is asked like that. Now, what is the effective resistance between A and B means whenever they're asking, always remember this technique. They're asking from this ends means go extreme ends, go to the extreme ends. It is always the better thing. Why means in extreme end, from AB is the first this side, left side, and at the right side end if you go, how these 3 resistances are there, they are one connected to another. Remaining nowhere I can say like that. Here 2, 2, 3, 2, 3, 2. I can't tell series because here 2 is connected. This 2, 3, 2 I can't tell series because 2 is connected here. 2 is connected here. But these two they are can be called as series combination. Series combination, one connected to another without any other resistances. For this branch, if you observe between these 2 points, these 2 are in series. So from that information, now what should I write here means, if you observe carefully here, this is 3 ohms, 2 ohms, and again this is also 2 ohms, 2 ohms, and this one is 3 ohms. And now this all combination series means 2 plus 2 plus 2, 2 plus 2 plus 2, we get it as 6 ohms. So I am writing 6. If you observe carefully this 6 and this one, so 3 and 6 are between same points, I can tell. 6 is also between these 2 points, 3 is also between same points. When they are in same points, I can call them. They are in what combination? Parallel combination. Distances between same points are called parallel combination. Parallel combination means I can write 6 into 3 by 6 plus 3. 6 into 3 by 6 plus 3. 18 by 9. That is nothing but 2 ohms. This is nothing but 2 ohms. So the value is 2 ohms here. Now you let us take the new page and check it out. What is the phenomena happening here? Here I have the resistances like this. This is 2 ohms, 2 ohms. And this one is how much beta? 3 ohms. Now, what happened here? I am taking again 2 and 2. And this value what we got just now, by calculating we got this one also too. Again, as previous, if you observe, if you take between these 2 points, how this last 2, 2, 2, how they are? These 2, 2, 2, they are in series. So 2 plus 2 plus 2 is equal to, we can write 6. Now, these are the points A and B. Again, 6 and 3, how they are? If you observe this value 6 and this value 3, if you observe 6 and 3, they are parallel because they are between same points. So now, what to write here in the next step? Here, this is a value 2, 2, and this value is 3, and this value is 6. Again, 3 and 6 if you observe. Again, 3 and 6 you observe. 3 parallel between these points. So 3 into 6 by 3 plus 6, that is 18 by 9. It is 2 ohms. So now between A and B, here 2 ohms we have. So 2, 2, 2, 2, if you observe all this resistance, 2 ohms, 2 ohms, 2 ohms between the points A and B. So what will happen? R effective, all are in series, all are in series. So final answer is 2 plus 2 plus 2 is equal to 6 ohms. Answer is 6 ohms. Like that, we have to solve this type of sum. Let us observe what we did here. First of all, in the question, they mentioned like this beta. The question, if you observe here, 2, 3, 2, 2, 3, 2, and last one 2, 2, 2, 2. Yeah, this 2, 2, 2, we can call it series. We can't call 2, 3, 2 as series because here and here distances are there. We can't call them series because your current, suppose coming from here, it will divide. We will not get the same current. 2 ohm and 3 ohm, the same current will not enter from 2 ohm to 3 ohm because your current divides. Current divides. So we can't call this as series. We can't call this as series, but we can call the ending one as series. All these three are one connected. Whatever the current enters here, the same current will flow here without any division. Same current will flow in these three. So these three are called as series combination. Series, just add 2 plus 2 plus 2, 6. Now we got this value, total value instead of this one I have taken now 6. And this is what? 3. 6 and 3, how they are? Parallel. 6 and 3, they are parallel now because they are between same points. Same point. 6 is also between these 2 points. 3 is also between these 2 points. Parallel means 6 into 3 by 6 plus 3, we got 2. So instead of this total one, I can write simply 2 here. I can write 2 here. Let us check in the next page here what I have written that one. So here I have written that is 2. Now this value I have written as 2. And this is already 2, 2, 2. If you observe now, these three are in series. These three are in series. As these three are in series, 2 plus 2 plus 2 plus 2, all the three combination, 2 plus 2 plus 2 is 6. So now if you observe how this 6 and this total I have written as 6 here. And this is what? 3 here. 6 and 3, 6 and 3 are parallel. 6 and 3 are parallel means 6 into 3 by 6 plus 3 is 2 ohms. So this value is 2 ohms and this value 2 and this value 2. 2, 2, 2, 2, how they are? Series combination, series combination. So just add those things, we'll get the answer as 6 ohms. I hope these things are clear beta. And now we'll see few more applications in this regard. So now the resistances combination, we are observing different types of combinations till now. Let us continue further how to handle all the resistances combinations problems in series and parallel. So let us check it out now. Here I am taking one new question. Here what happened means the resistances are like this. And they have given the resistance here also, one resistance. So again, here if you observe, I am taking one more resistance, one more resistance. So this one, if you observe between A and B are these points. And all are here, what happened mean this value I'm taking it as 2R and this value as 2R. And this is R, this is 2R, this is 2R. And this one I am taking it as 3R. And this one I am taking it as 3R. So now this one I am taking it as 3R by 2, 3R by 2. What is the effective resistance between A and B? What is the effective resistance between A and B? So then how to find effective resistance between A and B means as here it is A, I can write here also A. And this point is also A. And again this point is also A. It can't go further, it can't go like this because here resistance is here. It can't go this side, it is having resistance here. Maximum it can travel till here. I can even write the A point here also. But it can also be written as here also A point. And B I can write here. 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 So if you observe now carefully, this total, these two, how they are means, these two are, first of all, these two are in parallel. I can say these two are in parallel combination. So 2 are parallel. 2 are parallel. So 2 are parallel means I told you that 2R by 2 it will become as R. It will become as R. And this one also become as R. Now how R, how they are? R, triple R. It is not a movie. It is RRR. Is three resistances in series. Three resistances in series means, what should I write here? Three resistances in series means R plus R plus R, 3R. And one more 3R is there in the here. And one more here, one more resistance I can write here as, they have given it as 3R by 2. And these are the points A and B. I have rewritten the above one like this, B and B. So here now, how 3R and 3R, all the three, how they are, all the three are parallel. So to easily to solve, first you take only these two are parallel. First you take, anyhow all the three are parallel, but to solve it in easy way, I'm taking these two are in parallel. These two are in parallel means 3R parallel means I can write 3R by 2. Now you observe 3R by 2, another one is 3R by 2. So 3R by 2, 3R by 2 are again parallel between the points A and B. So points A and B. So these two are parallel means how to write? These two are parallel means I can write R effective is equal to 3R by 4. R effective is equal to 3R by 4. So this is my final answer for the given question. This one. I hope you understood how to handle this application now. So first what I did here, these two are in parallel. Again, these two are in parallel. Parallel means 2R parallel means 2R by 2. I got R. 2R parallel, I got 2R by 2. That is R. R. All the three R's are in series. So 3R. So 3R by 2. All the three are parallel now. So what I did here, first one 3R, second one 3R, third one 3R by 2. So at a time, I'm not calculating all are in parallel. First for these two, because these two are identical. These two are identical. So 3R identical. What I'm doing, I'm getting it as 3R by 2. Now 3R by 2, 3R by 2. If you observe this 3R by 2, this 3R by 2 again parallel. So 3R by 4. So like that, if you follow, it will be easy to handle. Let us see one more thing here. Here, they have given one resistance like this. Here this is 3R and this is 6R. And again, here what we are taking here 3R and 6R and this is again 3R. And this one is again, they have given it as, let us take this one as 2R, this one as 2R. This one has 2R. And this one I am writing it as again 3R, 3R, 3R. So how to handle this one means again what we are going to get here, you observe carefully here. So again I am writing this as 2R. Effective resistance between A and B. First of all, how to handle these situations means you observe how these 3R and 6R. First to concentrate on this one, 3R and 6R. They are parallel. 3R and 6R are parallel, I can say. So 3R and 6R are between same points. They are between same points. These 2 points, they are parallel. So 3R into 6R by 3R into 6R by 3R plus 6R. 3R into 6R by 3R plus 6R means I can write it as 2R. 2R I can write. So 2R and 2R how they are? 2R and 2R how they are? Series combination. 2R and 2R are in series combination means what we'll get here? So let us take the next page here. This is what we got here is 2R. And again I have here 2R. And again here I have 3R. And again finally I have here 2R. So now this is A, this is B. So this is also A, this is also A, this is B, this is B I can write. If this is A, I can make it to travel till here because there is no distances. B also can travel till here because there is no distances. Now if you observe this total combination 2R and 2R are in series, we can write 4R. And this is 3R. And this one is 2R. How to write when the three resistances are in parallel 2R, 3R, 4R means our formula R effective is equal to when three resistances in parallel, I can write R1, R2, R3 by R1, R2 plus R2, R3 plus R3, R1. This is the formula for three resistances in parallel, three non-identical resistances in parallel. Here R1 is equal to, first one is 4R, R2 is equal to 3R, and R3 is equal to 2R. Just if you substitute this one in the formula, you will get the answer. 4R into 3R into 2R by 4R into 3R plus 3R into 2R plus 2R into 4R. Everywhere 2R's will be cancelled. RR will be cancelled. This R will be cancelled. 2R's will be cancelled, numerator and denominator. So here in the numerator, 4 into 3. So what will get here? 12. 12 into 2, 24R in the numerator. 24R in the numerator. In the denominator, what will get here? 4 into 3, 12. And 3 into 2, 6. 12 plus 6, 18. Again, 2 into 4, 8. 18 plus 18. 18 plus 8, 26. So what we get here is 12, and if you cancel with 2, 12R by 13. Check the calculation here. Once is the calculation correct? R I cancel everywhere. 4 into 3, 12, 12 into 2, 24. In the denominator, 4 into 3, 12, 3 into 2, 6, 12 plus 6, 18. And 18 plus 2 into 4, 8. 18 plus 8, 26. So I got finally, if I cancel with 2, 12R by 13 is the answer. Like that, we have to solve the problems for finding effective resistance. I hope you understood these applications on effective resistance. We'll see more applications and more problems on this current electricity part related to resistances in my next class. Thank you, everyone.